In this video we're going to look at using the cosine rule to calculate the size of an angle this time. Before we were looking at how to use the cosine rule to calculate the length of a side and we were given this formula here. This formula is given in the exam. If we wish to calculate the size of an angle, what we're going to do is we're going to rearrange the formula to make it cos A equals. So we're going to make cos A the subject to the formula. So first thing I'm going to do is I don't want a negative 2b cos A, so I'm going to add 2b cos A to both sides. I'm doing that because I didn't want it to be negative. I'm going to add it to this side, and I'm going to add it to this side. Because when I do that, they would cancel here. So on the right hand side I would have A squared plus 2bc cos A, and that is equal to b squared plus c squared. I now am going to subtract a squared from both sides. So 2bc cos A equals b squared plus c squared, take away a squared, and finally I want it to be cos A equals, and at the moment cos A is being multiplied by 2bc. So I'm going to divide both sides by 2bc. I do that because it cancels here, and I find that cos A is equal to b squared plus c squared, take away a squared, over 2bc. This is the formula that we will be working with in this video. This formula is given to you in your exam, and we can use this formula to calculate the size of an angle. Okay, in this example, let's imagine we were asked to calculate the size of this angle in here, angle A. So what we need to think about is what formula should we be using. So we're asked to calculate an angle. So we've essentially either got the sine rule or the cosine rule, which you've just seen there. In this triangle we've got all three sides. When you know all three sides, that is a signal, that is a trigger that you should use the cosine rule. But when you're looking for an angle, you need to use the formula given. So it's cos A equals. Okay, so cos A equals b squared plus c squared, take away a squared, all over 2bc. Once again, that is given in your exam. Where do a, b and c come from? Well, they come from labelling our sides in the triangle. Okay, if we keep going, cos A equals 5 squared plus 6 squared, take away 7 squared, divided by 2 times 5 times 6. So that will give us cos A equal to, so that should give us cos A is equal to 0.2. Just be careful that when you're inputting this in your calculator, put brackets around both the top and the bottom line for when you're inputting into your calculator. Okay, so we want to find out the angle A. So A equals the inverse of cos inverse of 0.2, which comes to 78.5 degrees to 1 decimal place. Okay, so I knew to use the cosine rule there because I was asked to find an angle and I was given all three sides, and I knew to use this version in particular because this is the version that we kind of associate with the angle, because then it's just a straight inverse function of cos. We'll do one more example together. Okay, in the triangle XYZ, let's calculate the angle at Z. Okay, so we're asked to calculate an angle and we know all three sides, so we should use the cosine rule. So the cosine rule is cos A equals B squared plus C squared, take away A squared divided by 2BC. However, in this triangle we don't have ABC, we've got X, Y, Z, so we'll label our sides X, Y and Z. Okay, so the angle is at Z, and in the generic example the angle was at A, so it's going to be cos Z, and then linking within, if we compare it to the other formula we're given, it's going to be X squared plus Y squared, take away Z squared, all over 2x y. What we're going to do now is we're going to substitute these values in to calculate the size of cos of z. Okay, so cos of z equals 17 squared plus 9 squared, take away 10 squared, and that is divided by 2 times 17 times 9. Remember to put brackets around both the top and the bottom line. So cos of z will equal, so that's 0.882 keep that number on your calculator. Okay, and then to find out z, you'll do cos inverse of 0.882. So on your calculator you can just press cos inverse of answer, and when you do that you should find that your angle is 28.1 degrees, and that is to 1 decimal place. Okay, so once again we knew to use the cosine rule here because we had all three sides and we were asked for an angle. This is a generic cosine rule, so we just substituted the letters where appropriate, substituted in our values, making sure we had brackets in the top and bottom line here, and did cosine or cos inverse of our answer to get 28.1 degrees. Thank you very much.